we end up with 36. Do you see a pattern right here? Yes, exactly, because the difference of these immer pairs are divisible by 18. And that is the power of math. The power of math also allows us to extend beyond to infinity. That led us to hypothesize that these patterns exist for any immer, and by any immer, we mean infinitely many immers. So in order to prove that it is true for any pairs of immers, this is our justification. A number is divisible by 18 if it is divisible by 2 and divisible by 9. First, let's start with divisibility by 2. Since immers are prime numbers greater than 2, they are odd. Subtracting one odd number from another always results in an even number, which means the difference is divisible by 2. We have an example here. 13 and 31 are odd numbers, and if we get their difference, we have 18, which is an even number. Next, we move to the more complex part of our research, which is the divisibility by 9. Let P be an immer with n digits written in base 10. We express P as the image that follows. For example, we have an immer 71. We express 71 as 7 times 10 to the power of 1 plus 1 times 10 to the power of 0. And the digit reversal is also written in the same form. Now, if we take the difference of P minus Q, the digits eventually line up into inverse positions, and we apply the property of 1 modulo 9. 10 is congruent to 1 modulo 9. What does that mean? It means that if we divide 10 by 9, we get a remainder of 1. And therefore, 10 raised to k is equivalent to 1 modulo 9 for all k greater than or equal to 0. And then we reduce the number modulo 9, the powers of 10 disappear, and only the sum of the digit remains. And because the digits are arranged in reverse order, the difference naturally cancels each other out, and there's a row left in modulo 9. So we have 0 times 1 modulo 9 is congruent to 0 modulo 9. So the findings of our study is not only about the results, but also what it represents. Our research says that numbers are not random collections of digits. It follows clear structures and rules. It reinforces the very idea of number theory that patterns exist due to consistent number behavior, not by coincidence, but by mathematical principles. It may seem to you that our research is not very useful, but the study of primes and its related concepts are very much important to the foundation of cybersecurity that includes secure communication, online transactions, cryptography, data security, and digital verification. Our research also opened doors for further exploration, such as in number theory. Method can be applied to other special numbers such as palindromic and circular primes, and future studies may examine new operations and relationships involving immer numbers. Ladies and gentlemen, we end with this message. Patterns are not accidents, they are invitations. Invitations to think deeper, to ask better questions, and to appreciate mathematics not only for what it solves today, but what it makes possible for tomorrow. Quod erat demonstrandum. Thank you.
Thank you. We now open for Q&A session.
Okay, all right. So numbers are not random collection of bits. Very interesting quotes. Thank you for your presentation.
Thank you.
Maybe you could elaborate a bit more about the application. Maybe you can give example how this can be used for the application. You mentioned like secure communication, online transaction or cryptography. How can you explain a bit more on how the application of mathematics in the security? Thank you.
Actually, our study is a bit more theoretical, but as I said, it's the primes and immers are very contributes to the broader part of the mathematical foundation of cybersecurity because actually the mathematics for cybersecurity, computer science are discovered over 200 years ago. But it's only when the technology catches up that we are able to enjoy them today. So I think that's the same for our research, that it may not have a direct application today, but I think it opens doors for other things. Thank you.
Thank you. For the next Q&A session.
Thank you very much. I like this style, very pure, basic,
Thank you.
theoretical investigations. So can I ask how did you reach the research questions? Do you have, research question is clear, but how did you reach this research question? Did you have any occasion or experience to reach these questions?
Actually, it started out as a math investigation in our school. So we were told to more focus on primes, and that's we end up with IMERPs. I think it's what really fascinates us about IMERPs is that it's very unique primes because reversing digits usually destroys primality, but that's not the case for Immerse. We reached the research question by really examining what patterns can we see in the numbers. Like we started actually with divisibility by 2 and then by 9 and then we reached 18, and that's what we saw as the highest. And I think from that on, we really wanted to see if it's applicable for all Immerse because if we do that manually, it's gonna take. I didn't think it will take forever. So yeah, that's how we came up to that.
Thank you.
Thank you.
Thank you, Sujimura Sensei. Maybe for our last question.
Thank you for your presentation. Not so much about the research itself, but I was wondering, did you have any missions of joining Science Castle? Are you looking for collaborative partners, or are you looking for new questions that you can work on?
I think we were looking for more questions and really just wanting to share our research because we think it's very unique in a sense that it's math. It's purely math, and we wanted to see how people would perceive it, how we could share this information, and also learn from our co-researchers. Thank you.
Thank you.
Thank you, Toku-san. And thank you to the team from University of the Philippines High School in Iloilo. Please give them another round of applause.
All right, student, are you okay? Are you sure? Are you okay? Okay, if you're okay, now let's proceed with our 7th oral presentation from Nguyen Anin Secondary School. Please welcome them to the stage.
Good morning, everyone. My name is Kang, and I am the presenter of Nguyen An Ninh Secondary School Team, Vietnam. Today, our team will bring to the SCA 26 the project named Smart Boy System for Demarcating Safe Beach Zones. Okay. With this project, we aim to improve beach safety by creating a smart buoy system that can help support lifeguards and maintain a safe swimming boundary while swimming at real sea conditions. Today, we will introduce the problem, how the system works, our proposed solution, the field testing results, and the future development roadmap. First of all, the reason why we came up with this project is because in Vietnam, beach drowning risk can increase due to the changing of tides, waves, and wind. Traditional buoy ropes are still used to mark the safe swimming area. However, these kind of traditional buoy lines can still be affected by different harsh marine conditions. At low tide, the buoy line may At low tide, the buoy line may drift onto the beach. At high tide, the buoy line may be needed to be pulled closer to shore. This means that lifeguards had to manually adjust its position several times a day. Our key challenge is how can we maintain a clear, stable, and adaptive swimming boundary while reducing manual operation. To solve this problem, we propose a smart buoy system that is designed based on high technology. This smart buoy system is designed to automatically adjust its position, depends on the changing of waves and wind. It can move toward or away from the shore, ensuring that the swimming zone remain in its correct position. It also supports remote monitoring through a phone or computer. The Smart Buoy prototype also includes an SOS emergency alert function, which can help ensure that the swimming zone remain in its correct position. Moreover, it also can send urgent signals to the lifeguards and the control station, making that the lifeguards can respond quickly to the drowning people, making that the Smart Buoy system is not only a safety support device, but also a boundary marker. This system includes several main functions with different operating principles. First is the buoy body. The buoy body provides floating stability and buoyancy. The microcontroller processes sensor data and controls the system. The rotation angle sensor and the thrusters allow the buoy to move and adjust its position accordingly. The semi-controller can also process the sensor data and transmits this wireless data to the control station. The most interesting and eco-friendly part of the Smart Buoy system is the solar panel, which harvests clean energy to power the whole system. The estimated cost of this project is about $95 per buoy, making the Smart Buoy relatively affordable for further expansion. In real application, the Smart Buoy system can work together with an auxiliary buoy line, which helps mark the safe swimming area. This is really important because real beaches are not static and it can change throughout the day. Under the rip currents and the tide changes, the Smart Buoy system can semi-automatically or automatically adjust its position, maintaining a safe visual boundary for swimmers. It has also been tested several times at the local beach in my hometown. The Smart Buoy system has showed positive results and met the required criteria, not only in laboratories, but most importantly, in the real world. The Smart Buoy system includes three important values: innovation, applicability, and impact. In terms of innovation, the Smart Buoy system can automatically adjust its position depending on the harsh marine conditions. In terms of applicability, the Smart Buoy system can be suitable in many beaches, especially ones with harsh marine conditions. In terms of impact, the Smart Buoy system can improve beach safety and increase public confidence when swimming at the beach. The Smart Boy prototype has also received recognition through winning the second prize at the national level of Children's Youth and Innovation Contest. It is also highly appreciated by the Vietnamese newspapers and television. Moreover, it shows that the idea has real social value and potential for further expansion. In the future, the Smart Boy system can be developed into several directions. Cameras can be added to observe real beach conditions. Early warning AI can help us manage the data and send this data back to the control station, which in the long term would help the Smart Boy system become a really sustainable solution. In conclusion, the Smart Boy system can help offer a practical, affordable, and sustainable solution. Beach prevention, drowning prevention, and beach safety are still important public concerns. Each member of our team has contributed to a different part of the project, including research, design, and programming. Most importantly, the Smart Boy project not only requires technical knowledge, but most importantly, teamwork. Thank you for listening. We welcome your questions.
All right, thank you so much from Nguyen Anin Secondary School. Now we will open for the Q&A session. Okay, let's have our first question from Prof. Hafizal.
Thank you very much for your presentation. Very interesting innovation.
Thank you.
So I would like to clarify, you have developed this prototype, yes?
Yes.
Yes, okay. How long have you tested this prototype in the real environment? Have you tested in the real environment, or maybe in some limited pond, or in actual sea that you have tested? Where do you deploy this?
Oh, after to this prototype, we have tested the buoy 2 times. One time at a swimming pool and one time at a beach, and it can floated well, remain stable, did not flip over and move at the design. And we ensure the buoy can work well at the beach and can adjust its position and step automatically. And we have tested this buoy 2 times.
All right, thank you. My second question: how do you maintain the buoy position in the sea? So is a current is moving, water is moving. So how do you maintain its position?
The buoy uses the GPS and the 4 thrusters to adjust its position and depth automatically. And it has the waterproof ultrasonic underwater depth sensor to measure the distance from the buoy to the seabed. And we set a safe water depth in the program, so if the tide changes, the buoy can automatically move forward or backward to stay at the correct depth.
Thank you.
All right, thank you so much, Professor Hafizal. Now we proceed with the second question from Toke-san.
Thank you for your presentation, and I may have missed it when you were talking about it or presenting. Can you highlight once again what was your hypothesis in this research that you have done?
So the reason why we came up with this project is because in my hometown, the people that they swim can be accidentally drowned in real beach conditions. That's why we have came up with this project, so that we can reduce the drowning accidents and also to improve beach safety in further development and also in the future.
Thank you. If there's any data that you collected to improve your innovation, can you share with us?
So some of the data that we have collected from the Smart Boy system is the GPS and also the real-time location. As I have presented in the project earlier, it is said that the Smart Boy system can help the swimming and the people become stable inside the real sea conditions. Also that the real beach conditions are not static. So we have used the data of the buoy's position and also that the level of tides, the changes of winds and waves to measure and also to improve the smart buoy system.
Thank you. I think there's another question.
All right, thank you so much. Maybe we can have third question from Miss Norafiza.
Okay, thank you. So you mentioned you're using GPS, right? So what is the latency of your data? Meaning from one moment you track your buoy until the next time you track your buoy. What is the latency? How many, I mean, is it seconds or real time or?
It is real time, so it is immediately, the data can be immediately shown and it would send straight back to the control station or the lifeguards, which means that this smart buoy system is really practical and it can show the information, the data between the different times of where the position is suited inside the real sea conditions.
All right, thank you so much, Miss Norafiza. And I believe we can get one more question from Sujimura Sensei. Okay. I think pass to Dr. Shen.
Hi, great project. I like your engineering approach. I'm an engineer myself. My question is, why would you have a float instead of a boat? Do you want people to grab on it? What is your main objective here? If let's say there's an accident, people start to drown.
From my perspective, the smart buoy system, it doesn't stand alone, but it can be used with the smart auxiliary buoy line, which is also called the traditional buoy line. So if the smart buoy system moves, the whole auxiliary buoy line will move with it. So which means that although the people that is drowned are almost being drowned, they could they could grab onto this auxiliary buoy line and the smart buoy system would detect it and send it to the control station.
And what's the hardest challenge? Do you face any communication issues, power issues, anything that burn up? Can you tell me some stories where some challenges?
So we use an SOS emergency alert function. It is installed and it was put inside the waterproof acrylic box of the smart buoy system. And this data, whenever someone touches the buoy line or maybe the smart buoy system, it will send this data back to the control station or the lifeguards. And the lifeguards would respond faster and much more quickly.
Did you build it yourself, or your teammate helped you to build it?
While we doing this project, the idea that my team members and I are passionate about the technology, about the science, about the innovation, and we have a lot of ideas. But about the practical, we want to choose this project because we want to reduce the drowning accidents. And moreover, thanks to our teachers and thanks to PVU teachers, which is a University of Vietnam, to support our project and give support ours about the components, about the motors and sensors, to while we doing this project.
Thank you so much for listening. Yoroshiku onegai dashimasu.
All right, thank you so much from the Nguyen Anin Secondary School. Please give them a big round of applause.
Our next oral presentation will be presented by the team from Tokyo University of Agriculture, the first junior high school. Please welcome them to the stage. And for your information, their research title is Performance Comparison of Wavy Airfoil Sections. Please welcome.
Okay, so my title of my research is Performance Comparison of Wavy Airfoil Sections. So first, for everyone in this hall, have you ever wished you could fly freely through the sky? So it all started when I was tracking Santa Claus on February 24, when I found out many other airplanes, which sparked my interest in wings. And that's when I wondered why most wings are streamlined. And this is the state-of-the-art HWV design, featuring a design where the wings and the fuselage are integrated into a single unit. And that's when I wondered if these original ideas could be applied to a personal vehicle. So I like to try making the wings like the following. The wings that have the enjoyable design, a high lift-to-drag ratio, and generate their own power. I'm currently researching related to 1 and 2. So therefore, in 2024, I conducted this research so I can compare those 3 original airfoils with those 3 conventional designs. And in that research, the Wavy airfoil remains as the best candidate. And today's objective is to compare the airfoil's wave number and size and presence or absence of a tail, and conducting both lift and drag experiment, and also conducting wing tunnel experiment to get a clarifying a performance differences. So first, these are the airfoil types. Type A features a design with the waves to the same size. Type B features a design with the waves gradually slows down. And type S features a design with a tailless design of A6 and B6. So first, the lift experiment. So I wanted to do this experiment because I wanted to quantify the amount of upward force generated on a wing. And the experimental method is the wing is blown to the wing model, and the weight reduction due to the weight loss due to the lift generation is determined as lift, and the lift coefficient is determined. And the coefficient is a numerical value that represents a performance, even it remains even valid even when the wing is enlarged to its actual size. The measurement method involves taking 3 measurements per minute and calculating the average. And furthermore, for calculating the average value, a 10-second intervals over 1 minute is for one trial. So, hypothesis, A6 generates the biggest lift because I thought that it will overcome the leading edge shape 6 times, which may increase the lift generation. And as a result, there was no clear pattern was found in how wave number and size affects lift. And also, as you can see in that graph, the baseline airfoil actually had the best performance in the entire range. And next, the drag experiment. In this experiment, I wanted to quantify the amount of force generated on the wing by a wing pushing backwards against the wing. And the measurement method slightly differs from before. If the wing hits the wing model, the cart moves forward, lifting the weight suspended by the string, and the weight reduction is determined as drag. And hypothesis, I hypothesized that the A6 generates the biggest drag because it has the most surface area and high air resistance. And as a result, there was no clear pattern was found on how wave number and size affects drag. And also, as you can see, all increase in proportion to the angle of attack. And next, lift-to-drag ratio. So lift-to-drag ratio is a ratio of lift and drag of an aircraft, and I use it to quantify the amount of performance. And my hypothesis is based on airfoil, which is used in practical use, has the highest lift-to-drag ratio. And as a result, A4, A5, and B6 exceeded the baseline airfoil's performance. And also, overall, B6 performs the best. And next, the presence or absence of a tail. I conducted this study so I can know how it impacts if the tail impacts the lift-to-drag ratio. So compared wing is A6S1 and B6S2. And my hypothesis is I thought that the tail section will increase lift, so I hypothesized that the A6 and B6 have a higher lift-to-drag ratio. So as a result, there is no clear pattern was found how a tail affects wing performance. And number 3 is the airflow visualization. So I conducted this study because I wanted to clarify the reasons for the performance differences of the lift-to-drag ratio. And the method is angle of attack 20 degrees and 40, the whole wing model was used. And my hypothesis is for the baseline airfoil, it will become smooth and flow around the wing. And on a wavy airfoil with a high lift-to-drag ratio, will become wavy and flow along the wing. And on the low lift-to-drag ratio, it will experience turbulence. And as a result, as you can see, the baseline airfoil flow along the wing, but in the vortex form on third wave, and also multiple vortices form simultaneously from wave count was 4 or more. So that's when I investigated why does the lift-to-drag ratio increase even when the airflow is turbulent. So I thought that the airflow near the surface will gradually slow down due to surface friction. But however, a formation of vortices will make the fast and slow air to mix, and it will become more stable, which will make the slow airfoil more momentum and more faster. As a result, the slow airfoil will become more faster, and the pressure will decrease, lift to increase, and drag to decrease, which I've thought to have more higher lift-to-drag ratio. And for conclusions, A4, A5, and B6 exceeded the baseline airfoil, and number, size of waves that are presence or absence of a tail doesn't make a difference on the performance, and the difference in the number and generation location of vortices change the lift-to-drag ratio's outcome. And occurrence of vortices prevented the attachment and increased lift. And as a result, B6 was the best airfoil candidate for this experiment. Future prospects. In the future, I will develop wing design that intentionally generate those vortices, and also I will explore innovative wing designs inspired by flying creatures. And also I will use a 3D printer to make airfoils and equipment to improve research accuracy. Following our references, and thank you for your attention.
Thank you to the team from Tokyo University of Agriculture. We now open for Q&A session. Please welcome.
Thank you very much. I like this style experiment very much. And I like your talk as well. And my simple question is, I would like to ask you about the materials of the experimental airfoils. So can I get that information, for example, the materials or contents and
Okay, so
roughness or something like that?
So material of this airfoil is called styrofoam, which is like a stronger version of those, well, the 2024 designs. So I thought that will make the research accuracy more higher, and so I used the styrofoam.
Okay. And in the experiment, the wind speed is stable.
Mm-hmm. One more time, please.
Yeah. The experimental wind speed is always the same, or actually there are some graphs, but no wind speed is just a condition. So I would like to ask you the conditions of the wind speed.
Okay, so the condition of this experiment, environmental. Okay, so for the room temperature is about 28 degrees. I will set them all the same in every experiment, the lift, drag, and wing tunnel experiment, so I can like make the same condition as possible. Well, is that a good answer?
Also the wind velocities as well?
Oh,
wind that, so you prepared, how to say that?
Wind speed?
Yeah, wind speed.
So the wind speed is not written here, but it's actually 6.5 meters per second. And it is also.
Okay, thank you.
Thank you.
Thank you, Sujimura Sensei. Next question from Dr. Shen.
A very cool experiment. I'm an aerospace engineer and really like this.
Thanks.
Did you build your own wind tunnel?
Yes, so I made this wind tunnel by my own. I read some references how to get the best accuracy on those equipment. So yeah, I made my own.
Oh, that's really cool. What about the force measurement? Did you do that yourself also?
Yeah, I did myself.
Wow,
also.
amazing.
Thanks.
Yeah. So can you show me? Okay, is this a lift to drag ratio? What's the highest angle of attack you've tested all the way to 40 degrees?
So yes, this is 40 degrees because, well, in 30 degrees, almost every single airfoil is stalled out, and it won't make lift to drag ratio more higher. So in this experiment, it was only 40 degrees.
Ah, okay. And did you compare your airfoil to the other standard airfoil?
Yes.
The baseline. You call that the baseline airfoil?
Yeah, so baseline airflow is, as you can see in the graph, it's the red line. And that, the red, for the A4, A5, and B6, as you can see, it all exceeded the baseline airflow because I compared it.
So is this good for slow moving low velocities,
Well,
or higher velocities? Have you tested other speeds, other wind speeds?
so actually these airfoils can be used in low thrust. So it will make much lift, but with a little thrust.
Very good. Thank you very much.
Thank you very much.
Thank you, Dr. Shen. And thank you to the team from Tokyo University of Agriculture, the first junior high school. Please give them another big round of applause.
All right, students. So far, how the second round presentation? Are you enjoy? Are you focused? Are you pay attention to their presentation? Are you sure? All right, okay, ladies and gentlemen, now we will take a short 15 minutes break. Okay, to all students, please remain seated. May I invite our crew to assist the panel to the holding room for a short deliberation.
Side by side, young minds shine bright. Dreams ignite and knowledge flow. Science Castle, Science Castle. Yeah. Science Castle, Science Castle.
All right, thank you so much for your patience, student. We will take a break now. Please return to the
Please welcome.
Hi everyone. Good morning. Distinguished judges, teachers, guardians, and fellow students. I'm Miharu Maekawa from Namiki Secondary School in Japan. Thank you for the opportunity to present my research today. Oh, sorry. The title of my research is a wearable bio battery powered by sweat. My goal is to develop a battery that uses human sweat to generate electricity. In the future, it could power small wearable medical devices. Why did I start this research? During hot weather like today's, or exercise, we sweat a lot, right? Most people see sweat as something unpleasant, but sweat contains substances that can be used to generate electricity. Wearable devices are becoming more important. They can monitor our health, fitness, and physical condition. Future devices, like continuous glucose monitors, need a safe and reliable power source. Also, this made me ask, could our own sweat power the devices we wear? So, my research has developed over past 3 years. In 2023, I studied how sweat could work as an electrolyte in a voltaic battery. In 2024, I made a battery lighter, thinner, and more flexible. In 2025, I generate electricity from real human sweat. Thank you. This year, I changed the battery system to increase electricity generation. This is the basic structure of my wearable battery. It has two electro wires, Sadashi cloth, and a Korea plastic film. My goals are to make it lightweight, flexible, and low cost. These features make it comfortable and practical to wear. In my previous battery, I used copper and zinc electrodes with cross between them. Sweat acted as the electrolyte. However, metal electrodes are not ideal for long-term skin contact. So I tested carbon electrodes with microorganisms, and I used yeast as a microorganism because it is safe and easy to use. So in this year, I carried out 3 stages of experimentation. First, I investigated whether yeast could generate electricity from glucose. Second, I investigated electricity generation from lactic acid. Finally, I tested whether yeast could generate electricity from artificial sweat. For the first experiment, I could generate electricity from a glucose solution. And for the second experiment, I could generate electricity from lactic acid solution too. So today I'll introduce the final experiment because it was closer to using real human sweat. So that's why it is the most important step. The purpose of this experiment was to generate electricity from artificial sweat using yeast-based carbon electrode. I hypothesized that if yeast could generate electricity from glucose and lactic acid solution, it could also generate electricity from artificial sweat solution. So I prepared the electrodes in 3 steps. First, I mixed yeast with sodium arsenate. Next, I coated carbon seed with the mixture. Finally, I soaked them in calcium chloride solution. This formed a gel that held the yeast on the carbon electrode. After preparing the electrodes, I assembled the battery and add artificial sweat. Then I measured the battery's voltage and current. I repeated the test and calculated average to check if the battery produced electricity consistently. So I'd like to move on to the result. This graph shows the average results of the artificial sweat experiment. The blue bar shows the voltage and the red bar shows the current. The battery produced about 140 millivolts and 1 milliampere of current. These results shows the electrodes generate electricity with artificial sweat. At this stage, the battery does not produce enough electricity to power a wearable sensor. However, generating electricity with the electrodes is an important first step. These results suggest that microorganisms can be used in flexible carbon electrode for biobatteries. My first goal is to use skin microorganisms instead of yeast. I want to test if they can generate electricity from your human sweat too. My second goal is to improve the electrode design for more power and longer life. My final goal is to use this technology in wearable medical devices such as health sensors and continuing glucose monitors. My goal is to create a battery with 3 advantages. It should be eco-friendly by using natural materials. It should be long-lasting, so it needs fewer replacements. And it should be human-friendly, flexible, lightweight, and safe to wear. These are the references and acknowledgements. In conclusion, I developed yeast-based carbon electrodes that generate electricity from artificial sweat. Although the power is not yet enough for practical use, this is a step toward an eco-friendly wearable battery powered by sweat. Terima kasih.
Thank you. We now open for Q&A session.
A very good presentation and interesting experiment. So what is the minimum voltage and current to power up a sensor, and what would be your target maybe in the short term?
In start experiment. Okay. For my third experiment, the average volt is about around 100 millivolt, and ampere is like under 0.8 milliampere. So I think it can be used for the LED light. So it could not work for the medical devices or sensors with one devices, but if I put together the batteries, we can get more large amount of electricity, so we can use it for, yeah.
Thank you, Prof. Hafizal. Welcome for the next question.
Yeah, thank you. Thank you very much. And I like this experiment very much. And I also asked the results of experimental 3. And there are 5 samples. So I missed the information, but I would like to know the difference of conditions or materials or something among the 5 samples.
So you mean why I tested only 5?
Not only 5, but just I would like to confirm the difference.
Difference?
5 samples. So 5 samples,
I
the
see.
same or
Yeah.
different?
The 5 samples are same condition, and yes.
Okay, same conditions, understood. Apparently, it's very interesting for me that current and voltage seems to be much different between the samples, and also apparently there are no clear relationship between current and voltages. So do you have any ideas to interpret it that?
Yeah. Actually, I forgot to something to add this battery that is like catch the electricity on the plus side. So I tested this experiment in one solution. So the start is high. In start measuring, I can get high number of voltage and current, but during the experiment, the voltage and current is
Okay.
like growing lower.
Understood. So
Yeah.
such kind of experience should be very important for you. So make that experience very important and realize that. Remember that very.
Okay.
Thank you very much.
Thank you.
Thank you, Sujimura Sensei. Maybe one more question from our panel.
Okay, thank you. This is very interesting experiments. So how do you, if this is to be, in the future, if this is to be made, I mean, commercial or something, how do you plan to harvest the sweat for your battery from human body?
You mean what future goal?
I mean, if you were to extend this, you said that sweat can be used for battery, right? So, how would you collect sweats from human body?
Okay, actually, there are like Salashi crows in the battery, so the crows get together our sweat and how do I say? In this picture, like there are crows, right? There is a crows, and the crows like put together our sweat and send our sweat into the electrode. That's that's your answer. Makes
Okay.
sense?
Thank you, Ms. Norafiza, and thank you to the team
you so
from
much.
Ibaraki Prefectural Namiki Secondary School. Please give them a big round of applause.
All right, students, are you pay attention? Are you ready for the next presentation? Yes, please welcome our oral number 11, College Tunku Kursia. For your information, their research is about a machine learning framework for medicine education and navigated disposal. Please welcome College Tunku Kursia.
Assalamualaikum and a very good afternoon I bid to the respected judges, teachers, participants of Science Castle Asia 2026 and everyone present in this hall today. My name is Hanan and together with my teammates Zahra and Amira and together we're from Tunku Kusha College from Malaysia. So, do you know that there's a website out there that can exactly tell you which medicine in your cabinet is at risk of becoming waste and what you can do about it? Well, that's MAN. MAN stands for Machine Learning Framework for Medicine Education and Navigated Disposal Prediction. MAN brings together machine learning, medicine management, education, and navigated disposal all in one platform. But why do we need a platform like MAN? Well, let's take a look at the problem. So the problem is a lot more bigger than we might think. You see, around 30 to 50% of medicine are remain unused and many of them eventually expire in our home. So we have identified three main issues relating to this problem. First is ineffective inventory management. Many people don't know what medicine they have and when they expired. Second, unsafe disposal practice, because these unwanted medicine is then disposed and thrown away incorrectly and unsafely. And third, limited access to disposal facility, because even when people want to throw their medicine properly, they might just not know where to go. So we realize that medicine waste is not just a disposal problem. It is a problem about awareness, management, and accessibility altogether. So then this leads us to our two main objectives today. First, to reduce pharmaceutical waste and environmental pollution through predictive machine learning and proper medicine disposal, and to promote sustainable medicine management by improving public awareness. So we are not just trying to solve the disposal problem. We are trying to help people manage their medicine better in the first place. So now, to achieve this, MAN has developed several features within one platform. So first, users can manage their medicine through our medicine inventory. Our index-based search makes it easier for users to find information about their medicine. Next is our main feature, which is a machine learning prediction. So our system will analyze information about a medicine and its usage to estimate whether it is likely going to be a waste or not. And if disposal is needed, our GPS disposal navigation will help guide the users to the nearest verified disposal facilities such as the clinics, the hospital, and pharmacies. And not only that, we also provide medicine education through platforms like articles and forum, and also an AI assistant to help make users understand the responsibility of medicine management. Now, how do we build MAN? Well, our development followed a clear process. First, we identified the problem and designed the system. Second, we developed our database and our website application. Third, we developed our machine learning model. Then we integrated the multiple technologies, including the APIs, the geolocation, and also our AI assistant. And finally, we deployed and tested the system. But the most important part is how our machine learning prediction system works. Well, the process begins when a user adds a medicine. Our system will collect information such as the medicine name, the dosage, and the expiry date, and other relevant details. This information is then prepared for our machine learning model. We analyze key factors such as the storage duration, the quantity remaining, and user behavior and usage behavior. Then our model uses logistic regression to predict the probability of medicine wastage. This result then helps us identify medicine with a higher or a lower waste risk. And prediction is only the first step. If a medicine is in need of disposal, MAN will guide users to the nearest verified disposal center. And our AI assistant can also provide the users with educational guidance. So the flow is simple. You add a medicine, analyze it, predict the waste risk, guide the users, and enable safe disposal. So what did we actually build? So this is our developed MAN website. It brings together our medicine database, our index-based search, our AI prediction, our GPS navigation, our educational features, and also our analytic dashboards. So our medicine database consists of around 46,000 of medicine records. these records helps users to have a wider range to find information about their medicine. But the most important part is all of our features are connected. The prediction tell us what might happen. The education help guide users and to understand what they should do. And the navigation help users to find where to dispose this medicine properly. So this definitely turned man from a prediction into a real action. So now the main impact of man is that it changed the way we approach pharmaceutical waste. Because instead of dealing with waste after it happens, we aim to identify the risk earlier and provide and encourage action before this problem becomes a bigger problem. So then this can lead to a cleaner environment, to a less medicine waste, and to a better public health and to a better overall sustainable disposal. And to add, our analytics can also provide healthcare authorities with useful information about medicine disposal trends. So, MEN is not just a medicine database, it connects prediction, education, and action all together. So of course, MEN is still a developing platform. So therefore, our next step is to include a nationwide rollout because currently for our GPS geolocation is only catered to location around Kuala Lumpur and Selangor only. And not only that, we also aim to make MEN a mobile application so that MEN can be accessible to everyone. And for machine learning component, we aim to improve our model by collecting more real-world data and also to try and evaluate other and different approaches. And also aim to integrate MEN with healthcare institution and adding an OCR level recognition so it's easier for users to add their medicine in MEN. And now these are the SDG that MEN contributes, such as the SDG 3, SDG 6, SDG 9, SDG 12, and SDG 17. So now, to conclude, medicine are meant to heal us, not harm our environment. We don't just want to manage medicine waste. We want to prevent it before it even happens. With that, thank you for listening.
All right, thank you so much, College Tengku Kersan. Now, we will open for the Q&A session. All right, can we have the first question from Toke-san?
Thank you for your presentation. Can I know where you foresee limitation in your research and how would you plan to overcome those limitations?
All right. So one of the very few limitations that we face during developing MEN is first there is a lack of real world data about waste, about medicine waste, and then second, as my partner has told you earlier, we're from Tugukusha College. Meaning to say that we come from a residential school, so we lack the time to actually have our iPad or our devices 24/7, where we are able to actually use our devices a lot of because of the fact that we live in residential school, the time limit that we have to do our research is there. So we need to put a lot of effort in time managing and also in managing the website as a whole. I hope that answers the question.
So you are not able to access the data to do your research is what you are saying?
Yes, because currently we have tried to find every single real world data about waste medicine, but currently there is a lack of data about this medicine waste in the first place. So in future improvement, we will want to add more real data into our website, so to increase the accuracy and also the efficiency of medicine.
Thank you so much,
you.
Toke-san. Maybe we can proceed for the next question from Ms. Nora Fiza. So much.
Thank you. So you said that in your results you have already 46,000 medicine types of medicine you put in your database. So where you get it from, or is it integrated from other database, or you keep? I don't think you keep in manually 46,000, right? So how did you get it?
Alright, so our medicine data, the 46,000, we took it from a verified and authorized data, for example, NPRA, and it is also FDA approved to actually verify all in the we also integrate data from WHO.
Okay. So one more thing I just want to ask is this a live website? You
Yes,
develop it yourself?
any of the judges that want to open their devices, you can search mensproposal.com. It is an alive website as decentralized, Kuala Lumpur and Selangor. But yeah, for the geolocation, but for the inventory and also for the dashboard, people from even like on the international level can access to it. But currently, the geolocation and the GPS is only centralized around Kuala Lumpur and Selangor.
Great. Thank you.
All right, thank you so much, Ms. Nur Hafiza. Okay, we now proceed with the next question from Prof. Hafizal.
Thank you for your presentation. What specific machine learning model that you have used for your work?
Right. So for our machine learning model, we use logistic regression. And to conclude, basically we have tried to use or we have tried to analyze how other machine learning work. For example, we do random forest and also GX boost, but then we came up with logistic regression because it is the most lightweight and it is the most explainable. Because we do realize that this website is probably going to be used by elderly who have a lot of medicines to like navigate and like to manage, right? So we wanted this web to be as explainable and as accessible for all of the people that would probably want to use this website. Thank you.
Thank you so much, Prof. Hafizal. So maybe last question from the panel. So if no question, all right, thank you so much, College Tunku Kursia.
Thank you.
Please give them a big round of applause.
Now, before our final oral presentation, I want to know whether you guys are still energetic or not. So can I hear sun? Nah, not enough, not enough. Again, sun. Okay, so for our final oral presentation, it will be delivered by the team from Sekolah Indonesia Kuala Lumpur. Please welcome. And for your information, their research title is Hive Mind, a smart beehive computer vision AI framework for varroa mite detection. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Now, before I start, let me ask you a question. Do you guys see the tip of your fingertips? Do you believe me when I say that there's something as small as our fingertips that could devastate a whole bee colony? Good morning, my name is Yusuf Nabil from Sekolah Indonesia Kuala Lumpur. When we think of disasters, we typically think of something big, such as storms, earthquakes, or tornadoes. But in the world of bee agriculture, the biggest disasters are typically invisible to us. Now, I'm very excited to show you guys about our ongoing innovation, HiveMind, a smart beehive computer vision AI framework for varroa mite detection. Now, before I talk about the threat, let's talk about the bees. It's not a stretch when I say this, but bees might be the most important animal in the world. Why do I say this? Well, over 80% of all wildflowers need bees to even reproduce. Bees contribute to over 87 of the world's leading crops. And not only that, economically, bees contribute to over 150 billion USD each year. To put it simply, no bees, no food, no future. Now, funny enough, our passion started with this little game on Roblox called Bee Swarm Simulator. What started as a silly game sprouted into an actual passion, and as I got older, I learned about the arch nemesis of the bees. Let me introduce you to the varroa mite. These little guys are just as small as our fingertips, but they could devastate a whole bee colony within just 3 years. And the way they work is that they attach themselves to the honeybee's body and basically sucks all their life forces and that spreads deadly diseases. Within the last decade alone, these mites have wiped out over 1.6 million million bee colonies in the world. And this year, the bee mortality rate have reached an all-time high, which is 55%. Now, to learn more about this threat, we visited a local bee farm in Sijangkang, and after a quick interview with one of the beekeepers, we deducted 3 main problems. First, the varroa mite is an actual threat even to local local Malaysian beehives. Second, the way they deal with these hives typically is by manually inspecting them, which is very time intensive and labor intensive. Third, uh, traditionally, they use a chemical-based pesticide to deal with these mites, which endangers the bees. Now, with these problems in mind, let us introduce you to the hive mind. The development process started in two ways for the hardware and the software. For the hardware, these are the main parts, and the main three parts to take note of are the Raspberry Pi, the Pi camera, and the mini vacuum. For the software, we utilize an object detection model called YOLO. We train it using 5,000 images and 11,000 instances of Varroa mite. To find the best YOLO model for our prototype, we benchmarked a few YOLO models and put them to the test. Although heavier models have higher accuracy rates, they were far too slow for our prototype. We chose the YOLO 26N model for its high accuracy and also high FPS. Now, to see the true capabilities of our AI, let's take a look at our confusion matrix. The green line shows the Varroa mite metrics, and it reached an astonishing 95% Varroa accuracy. And in practice, this means out of 1,000 Varroa mites, it will detect 950 of them. The confidence curve is also very good. If you see the purple line, which is the Varroa, it reached an average of 0.894 accuracy score, and overall this means that our AI doesn't just guess; it actively detects these parasites with confidence. Now, how does HiveMind work exactly? So it follows three main stages. The first stage is the camera. The camera acts as a mini security guard and actively sees the bees going in and out. Second, the YOLO model actively detects if there's an affected bee or varroa or not. And if there is a varroa mite, it will alert the beekeepers and also activate the separation process via the vacuum. Now, to test HiveMind, we used 50 test samples of varroa mite, and it came out with a 92% success rate, only missing 4 of them. HiveMind proves that through innovation, we could bridge the gap between a biological problem with a technological solution. And we believe that HiveMind is an alternative solution from the chemical induced that the the endangers the bees. Sorry. For the future, we wish to improve HiveMind in 3 ways. First, a solar-based power system for continuous use. Second, an automatic heat system to automatically kill the varroa mites. And third, a scalable mesh network to connect all hive minds into one big hive mind. In conclusion, we admit that it's still an ongoing research, and even though lab testing show a promising 92% success rate, our goal in HiveMind is to move beyond passive detection and actively stop these mites once and for all. And once again, my name is Yusuf Nabil from Sekolah Indonesia Kuala Lumpur. I'm from Team HiveMind. This is my team. Special thanks to our mentors, and here at HiveMind, we only have one wish, is to save the bee colonies, all the bee colonies in the world, one bee at a time. Thank you very much.
Thank you, Sekolah Indonesia Kuala Lumpur, for the presentation. We now open for Q&A session.
Hi, great engineering approach to a very unconventional problem. What's the vacuum for?
The vacuum is for the separation process. So when the camera detects an affected bee, the vacuum will activate and separate the bees from going into the hive.
And what happens to the sick bees?
Sick bees will go into like a separated container that closes off from the main entrance.
And what is your detection accuracy?
So from the 50 samples we tested, our detection accuracy reached 92% success rate, and it only missed 4 of them.
And do you connect your device to the internet? Is it an IoT? Do you connect your device to the internet so you will be able to monitor what's going on live, or you collect the data later?
The data is collected later. Actually, HiveMind is used for local beehives where which the distance is not that long, and maybe further internet is not yet available.
Okay, thanks.
Thank you, Dr. Sham, for the question. Please welcome Prof.
Okay,
Hafiza.
all right. You have selected YOLO for your project, and you have tested several YOLO models. So my first question, why you have selected YOLO, not other CNN model?
Because from our observations, YOLO models in general prove to show the best accuracy and also the best FPS for a microcontroller such as the Raspberry Pi. It actively detects these mites without any long latency.
Okay, another question is that you mentioned that you have 5,000 data set from here. So where 5,000 images? So where do you get these images from?
Okay, so the 5,000 images, we got it through the internet. Yeah. From like official website.
Which website?
We sourced it from a trusted database by the apiary. Wait, what's it called? The Apiary International of America. It's like images of the diseased bees and everything that has to do with apiary.
Okay, thank you.
Thank you, Prof. Hafiza. We would like to open one more question. Thank you, Prof. Hafiza.
Maybe one last question from me also. For the data set, for 5,000 data set, so how this divided into different classes or different type of images?
Originally, we wanted to use 4 main classes, but our usage of majority of the raw mite is actually intentional to maximize the efficiency rate to detect these mites, and to detect these mites with different light conditions also.
All right. Thank you, Prof. Hafiza. And thank you to the team from Sekolah Indonesia Kuala Lumpur. Please give them another big round of applause.
All right, thank you so much to our final presenting team. With that, we have now concluded all 11 oral presentation. Congratulations to every participating students team for presenting your research with such courage and clarity. Please again give them a big round of applause. Before that, may I kindly request all the students to remain seated, and I would like to invite our crew members to assist our panel to proceed to the holding room for the further discussion and deliberation. Dear teachers, students, ladies and gentlemen, that concludes our oral presentation session. We extend our sincere appreciation to all the panelists and all the presenters. We'll have a break, lunch break, from now until 1:50. Please make sure to come back at the hall by 5:50 because after this afternoon we will have a workshop session. All right, okay? Are you here? Sa? Hi. All right, let's have a lunch break and please come back to the hall at 1:50, okay? All right. Have a good break.
So workshop ni kat sini ke?